Hi guys, welcome back to another video, and in this video I'm going to be showing you how to make a Wi-Fi jammer in Python. This video will be broken into two sections. The first section would be me talking about how this program works, what are the different functionalities in this program, and how do we implement those functionality. Basically, the theoretical part of this video is going to be the first section. I'm also going to be giving you a basic idea of the Wi-Fi architecture and the exact flaw in the Wi-Fi architecture that we are going to be exploiting. And the second section would be the actual scripting of the tool, the actual programming of the jammer. So if you're only interested in that section, you could skip to that part, but I would highly recommend you to watch the first section also, because it's more easier to follow the code once you know what's happening in the theory. It's more fun, it's more easy to follow. And this entire project is on my GitHub. The link to it would be in the description box below. You can check it out. And apart from that, there are a couple of prerequisites for this video. First of all, you need to have a Linux distribution. I'm going to be using Kali for my video, and you could use Ubuntu, Fedora, Debian, Arch Linux, whatever you want. And you also need to have an external Wi-Fi card. The Wi-Fi card, which generally comes with laptop, which is pre-built in a laptop, does not support promiscuous or monitor mode and packet injection mode. So you need to get an external Wi-Fi card which supports both of them. I'm going to be using an Alpha Network Wi-Fi card, which costed me around 6,000 rupees. I got this like 4 or 5 years ago. I don't know the current prices, but at that time it costed me around 6,000 rupees. And it's pretty cheap actually. You can get it off Amazon. And I also expect you to have a basic knowledge of Python and Scapy. Scapy, if you don't know, it's a packet manipulation tool which helps you to basically build packets, add different layers to a packet, and send those packets to layer 2 or layer 3. So all that being said, let's get started with the first section. So this Wi-Fi jammer program would have three functionalities. The first functionality would be it would scan for access points, and the scanning for access points would be done by we're going to be using Scapy. Scapy is going to be the backbone of this entire program, and the way we scan for access points is we're going to be looking for some packets which are called as beacon frames. If you don't know what beacon frames are, beacon frames look like this, and this is the general structure of a beacon frame. And in this beacon frame, we are looking for three things: the name of the network, the MAC ID of the network, and the channel on which the network is operating. So the name would be in the SSID over here, the MAC ID would be the BSS ID, and the channel would be inside the DS parameter set. So if I go here while we are scanning for .11 beacons, you could see that we are .11 ELT DSS set. It's a way to address this section in Scapy, and we are extracting the channel frame from here, and then we are extracting the channel number from the channel frame. If you don't understand this code, don't worry, because in the second section of this video, we are going to be writing this entire code line by line. This part is just me giving you a very basic idea of what this program does, so it would be more easier for you to code also, right? So even if you don't understand what all of this is, if it makes no sense to you, don't worry, trust me, it would make a lot of sense once we start the actual scripting. So we look for access points by sniffing for beacon frames, and another thing which I wanted to discuss was channel hopping. So any wireless network works on different channels. I think in India there are 14 channels, in USA there are 12 channels, but whatever, I don't know the exact number, you can look it up on Google. But over here we have the channels list, and what exactly I want to say is, let's say I'll open up Notepad. Let's say there are two networks, there is network X and network Y. Let's say network V, and we want to sniff both the networks. Network X is running on channel 3, let's say, and network Y is running on channel 7, let's say. So you can only sniff packets out of one channel at the given instant. So what you need to do is you need to hop continuously between channels. So Scapy does not by default provide a hopping function, so we need to code that ourselves. And over here is the logic, the channel hopper logic, which I had written. It's over here actually. It's the same thing. So what it does is it's an infinite loop in which we select a random channel from the channels list. Here we have the channels list. So we select a random channel from the channels list, and then we use the os.system module to inject a system command in which we set the whatever interface which we are using, the iFace, to the channel which we had randomly picked. And then we sleep for 0.2 seconds. So basically we are randomly switching to different channels every 0.2 seconds. That's how the channel hopper thread works. So we are going to be starting this thread before we start sniffing. So this is where we start sniffing, and the thread is here is where we start the hopper thread. and once we are done sniffing, there is something called as the daemon flag, which we set to false, which would then kill this thread. So this was the first function of the program. The second function is when we select a network, out of all the networks that we have sniffed, we scan for the clients which are present on that network. What I want to say is, in the previous example, we had, let's say, network X and Y working on channel 3 and 7 respectively. Let's say we want to jam the network X. We select the network X, and then we would be looking for different clients or different devices which are connected to network X. So that is done in the second section of this program, and that is achieved using scanning for these 4 packets: quality of service frame, quality of service with CCMP cipher frame, control block frame, and null frame. That would be somewhere here. So this is the access point scanning logic, and down here would be when we scan for clients. So here we have the client filter function, and over here we are sniffing for client's packet. So every packet that we sniff, we are sending that to the client filter function, and the client filter function is accepting that packet. And over here we have the entire logic. This is the logic for scanning the QoS packet. QoS with CCMP cipher should be here also. It should be somewhere here. QoS with CCMP cipher, control block frame, and null frame. I have said this before, but I'll repeat it again. Don't worry if you don't understand this. This entire logic is built on how the structure of the QoS packet or the CCMP packet. We're going to be using Wireshark to deduce all of this stuff. It's going to be way more clear now. So when we find a client on that network, we're going to be appending that client to the clients array, which we have made over here. And then the third section of this program is we would be crafting the authentication packets, and we are going to be sending those packets to layer 2 using sendp. So what I want to say is, we create an infinite loop, and then we loop through the clients array. Then we build a packet. The first layer would be radio tap layer, second would be the .11 layer, and third would be the authentication layer. That's the .11 the auth layer. And in the second .11 packet, there would be 3 parameters: address 1, 2, and 3. 2 and 3 would be the MAC ID of the network which we want to jam, and 1 would be the specific client which we want to jam. And then we, after building this packet, we send that on layer 2 using sendp. So if you know basic Scapy, send means sending the packets on layer 3, but for our purpose we need to send the packet on layer 2. So we'll use sendp, and we send the packet to the interface iface. And if you have ever worked in a similar project before, you could be asking one question, that why not set the address 1 to ff colon ff colon 6 times ff colon ff, basically the broadcast MAC ID, which would be over here. Yes, why not to set the address 1 to the broadcast MAC ID to automatically deauthenticate all the clients from that network. So I have talked about this issue at this beginning also, that this program sends unicast packets instead of broadcasting those packets, because a broadcast deauthentication packet attack never works. And theoretically it could work, but practically it never works. You could try it out for yourself, but it never works when I tried it out. So that's why we're going to be using this unicast method. And one thing which I forgot to discuss was how to run this program, right? So we call in Python jammer.py, we mentioned the interface, and then we mentioned the noise filter flag. All right, so first I'll explain the interface. I already expect the interface should be having the monitor mode on. Not generally, all the time. The first time you connect an external interface, it's going to be in managed mode. To switch it to monitor mode, first of all, what you need to do is you need to kill any kind of process which would interfere in the monitor mode of your Wi-Fi card. So you do that using airmon ng check kill. So if you only type airmon ng check, it would check for all the functions which could interfere with your Wi-Fi card running in monitor mode. In my case, there are generally 2 functions: the network manager and the WPS supply client or something. And if you type in airmon ng check kill, it would automatically kill those processes. And now to switch your Wi-Fi card from managed to monitor mode, there are 2 methods. The first is the manual method, that is ifconfig WLAN 0 down, and iwconfig WLAN 0 mode monitor, then ifconfig WLAN 0 up. This would switch your Wi-Fi card from, this should be down, I'm sorry. This would switch your Wi-Fi card from managed to monitor mode. And then when you want to switch it back to normal mode, you could just switch this from monitor to managed. but in our case we want it to be in monitor mode, so we'll switch it to monitor. And a very automatic way to do it using airmon ng would be to write airmon ng start LAN 0. This would start monitoring on LAN 0 interface. The only caveat being that it would airmon ng. The only caveat being that it would switch the name of this wireless card from LAN 0 to LAN 0 mon. And then to bring this back from monitor to managed mode, you could just do airmon ng stop LAN 0 mon. So this would work. So once the monitor mode is set up, you could pass that the name of the Wi-Fi, whatever it is, LAN 0 of LAN 0 mon over here. And the noise filter flag is, let's say while we are scanning for access points, I said we are looking for three things. We are looking for the name, the MAC ID, and the channel. Sometimes you could encounter some beacon frames which have a channel, which have a BSS ID, but they do not have a name. So I have categorized them as noise. And to see those noise, we could set this filter to 1. So, to not see those flags, we could set this filter to 1. So basically, when this filter is 1, the noise filter is true. It's working. So those noise would not be seen. But when this filter is 0, when the value is 0, the filter would not be working. So we could be seeing those noise also. So it's a little bit more clearer to have this set to be 1. But anyways, you could do it if you're like, if you want to do it, you could do it. There's nothing harm in it. But anyways, so that concludes the first section of this video. In the next section, we are going to be building this tool. We are going to be starting from absolute scratch. We're going to be importing all of these packages. We're going to be implementing all of these functions, and I'll see you there. Hi guys, welcome to the second section of this video. So we're going to be coding this entire program right now. First of all, you need to connect your wireless card to your virtual machine. I have connected my external wireless card to my Kali machine. So if I do iwconfig, you would see LAN 0, but it's in managed mode. So we need to switch this from managed to monitor mode. So the first thing you do is airmon ng check kill. This would kill any process which would interfere with your wireless card being in monitor mode. And then we could just do ifconfig LAN 0 down, iwconfig LAN 0 mode monitor, ifconfig LAN 0 up. So this would switch your wireless card from managed to monitor mode. So if you do iwconfig again, we would see LAN 0 is in monitor mode. So our wireless card is now in monitor mode. So we are all set to start the coding of the file. So I've kind of made a to-do list over here. So the first thing which we want to do is we want to make a channel hopper function. Second thing which we want to do is we want to sniff for beacon frames to scan for access points. So we want to implement these two functionalities first. So the first thing which I want to do is I want to give you a rundown of Scapy. How do we actually sniff packets in Scapy, and kind of a little basic crash course, and also the structure of the beacon frames, which is going to be very helpful. So first, let me go to my desktop, and then let's do mousepad.jammer.py. So it's an empty Python file. So let me open another terminal, and now we go to Scapy. Before going to Scapy, I have my mobile hotspot running on channel number 6, and I think it would be a good practice to do all kind of testing on my network. So to manually set the channel to whatever number which you want. We're going to be doing this while we implement the channel hopper function also, but just manually setting that to channel 6. Channel 6 is where my mobile hotspot is running. So what we do is we type in sudo iwdev LAN 0 set channel 6. LAN 0 would be the interface whose channel which you want to change, and 6 would be the channel which you want to change the interface to. So we do that, then we open Scapy, and then we set conf.iface is equal to LAN 0. If we don't do that, we'll have to specify the interface every time we sniff packets, so it's a bit easier. And then let me sniff some packets. So the way we sniff packets is we give a variable name, and that should equate to the sniff function, and we could pass a count parameter to basically tell this Scapy we want to sniff n number of packets. So let's say we want to sniff 10 packets. So let's do package.n summary, and now you can see, just make it a bit smaller. Now you can see there is a lot of stuff happening, but what we are considered with right now, if I open my to-do list, is, see, the channel hopper function is very easy to make. We are considered with sniffing for beacon frames, right? So you'd be looking for the word beacon frames. So if I open Scapy, you would see that here we have a management beacon frame, and then this is the name of my mobile hotspot. So let me grab this packet. So this was packet, so we can do packet is equal to packets, and the number would be 1. Let me clear the screen, and let me just put this over here. This should be here, and this should be here. Okay, 1 second. Yep. So let's do packet.show, and here you go. So this is how a management frame looks like. Not a management frame. This is what a beacon frame looks like, basically a Wi-Fi beacon frame. First of all, we have the radio tap layer at the top, and then the radio tap layer encapsulates all of the layers below it. So the layer below it is the 802.11 layer. The layer below it is the beacon frame, and the layer below it is the ILT frame, and then we have a lot of other stuff. So we could see that we are only considered with 3 things over here: the address 2, which is the address of my Wi-Fi network, and we are considered with the name. The name is in the ILT section in the info over here, and the channel number. So channel is in the DSS parameter set. So here you go. So we need to extract these 3 stuff from our packet which we have over here. So what we could do is we could first of all we could write a logic to see that the packet which we have captured has a beacon frame or not. So to basically see all the different layers which Scapy has basically already passed for us, we could, let me just run another instance of Scapy, and I think it was LSC if I'm not wrong. There was also a GUI version of LSC, but I don't remember that. But anyway, I think this would be good enough. Oh, it was LS, I guess. Okay, Explore, there you go. Explore was the GUI version. So the layers we want to work with 802.11 layers, which should be, okay, where is it? Yep, there you go. Wireless LAN according to IEEE 802.11. So now you see these are the different layers which we have. So we need to check whether the layer has .11 beacon or not. So let me just do clear the screen, and if, let's say, not if, let's say packet.has layer. So this would return a boolean value depending whether it has that layer or not. So if it has the .11 beacon layer, .11 beacon layer, you see it returns true. So we would be writing this logic into our file to basically enumerate whether a packet has the beacon frame or not, because not every packet is going to having the beacon frame. And after we have done that, if we just do packet.show, once we know that the packet is a .11 beacon packet, we could just grab different layers to get the information we want. For an example, to get the channel name, we could grab the DSS parameter set, and the way to grab it, I guess, would be it should be here. DSS parameter, ELT DSS parameter set. ELT is basically all the information elements are accumulated under the ELT name. So .11 ELT DSS set. So what we do is we clear the screen, and let's say DSS frame is equal to packet.getLayer. We get the layer. Like there are 2 main functions which we're going to be using, has layer and get layer. So we use the has layer to check whether the packet had beacon frame or not, and when it did have the beacon frame, we're going to be getting the DSS frame. So the frame exact name is .11 ELT DSS set in Pascal case. So .11 ELT DSS set, and then we could just do DSS underscore frame dot channel. Let's first see the frame itself. So you see this is exactly it's look a bit different, but it is exactly what we had seen previously. So I guess if we do dot show, it should be more easier to see. So all the basically all the encapsulation which was above this is gone now. We are only dealing with this. So you could see that if we do dot channel, we could get what we were looking for. So let me just clear the screen again, and channel is equal to DSS frame dot channel, and once we type in channel, we see we have got the channel number. So all right, we have the channel number now. So let's move on to capture the Wi-Fi name and the MAC ID. So let's again see the packet. The Wi-Fi name was over here in the information element, and the MAC ID was in the dot 802.11 frame, and over there in the address 2 we had the MAC ID of the network. So what we could do is we could first let's get the MAC ID. So for to do that, we get the 802.11 or the dot 11 layer. So we type in dot 11 layer is equal to packet dot get layer, and we will be getting the dot 11 layer, and then we could just do MAC ID is equal to dot 11 layer dot address 2, or even 3 would work. So if you do MAC ID now, there you go, we have the MAC ID also now. And if you remember what the packet looked like, the structure of the packet, this was the name over here, or above, but above here we have the name, and the name is below the beacon frame. So what we could do is we could get the beacon frame layer, and there is a built-in dot method which is called the payload. So if we let's say we get the radio tap layer, the payload of the radio tap layer is going to be everything below it. If we get the dot 11 layer, the payload of the dot 11 layer would be everything below it. And if we get the beacon layer, the beacon frame, the payload would be everything below it. So we could just get the beacon frame, then we could get the dot payload, and then we could do info. Or basically, we could just get the beacon frame, and then we could append dot payload dot info to get the name of our device. So that's what we're going to be doing. So let me clear the screen. 1 second. And then we do beacon frame is equal to packet dot get layer dot 11 beacon. Then we could do beacon frame. Okay, I'll just show you what I meant when I said the payload thing. So we have the beacon frame now. So if we show the beacon frame, you see that we have the beacon frame, and then below we have the ILT in which we have the name. So let's do beacon frame dot payload dot show. So over here you would see the beacon frame itself is gone. 1 second. There you go. We ran this command over here. The beacon frame itself is gone, and now we have one layer below it, one encapsulation layer below it. So to get the name, we could just do name is okay. You could just do name is equal to beacon frame dot payload dot name, and when we let's clear the screen. When we do name, we should have the name. Okay, it shouldn't be name, it should be info. I'm sorry, I think it should be info. And let's do name again. There you go. The name is in binary. If you would see over here, this is this B before the code denote this is in binary. So to decode this, you could just do name dot decode, and you could use the ASCII argument, and okay, name should be equal to name dot decode. So once we have done that, if we do name again, we would have the name. So now we have the name, the MAC ID, and the channel. So this is basically how we're going to be enumerating Wi-Fi access points. So we're going to be basically writing this logic in Scapy. So now I think we are good to go. So I'll just open up the packet again. We're going to be using this as a I want to clear the screen first. We're going to be using this as a reference while we are creating the program. It's going to be very helpful. So to import Scapy, the first thing we do is we type in from scapy.all, we import everything. And then we want to first of all define the different channels, right? We want to write a channel hopper function. I can never type properly when I'm recording. So we need to write a channel hopper function. So for that, we need to define a channels array. Why do we need to define a channels array? Because it's going to be randomly picking a channel from the channels array and it's going to be switching to it. So let's just define the channels array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we now need to write the channel hopper function. So the function name would be channel hopper, and it's going to be running an infinite loop while true. And while it is true, we would select a random channel from the channels list. And to select that, we would be requiring a package in Python which is called the random package. So import random, and then the channel would be there is a function in the channels in the random package which is called as choice. So we're going to be using that to get a random choice out of a list. So random dot choice, and from channels. So we would have now the random channel from the channels list, and then we could just change. We could be using the os.system to basically inject a system command. So we need to import os also. So os.system, and then we're going to be using string formatting over here. But also I want to define an interface variable, because it's not always that the IPS would be equal to VLAN 0. So we could change that using one general variable, kind of a global variable. So the code was iwdev, and then we write the name of the interface. So we're going to be using string formatting for that, and then set channel to again string formatting, and then we write dot format, and then first argument would be iFace, and then the second argument would be the channel which we have selected. And then we're going to be sleeping for a couple of, not a couple of seconds, maybe 0.5. In the original project, the sleep was for 0.2 seconds. So let's also implement the sleep for 0.2 seconds. Time dot sleep 0.2, and also we need to import the time package. So let's give you a basic rundown of what's happening. Channel hopper function, it would run in an infinite loop, select a random channel out of the channels list. It would inject a system command to switch the iFace to that channel, and then it would sleep for 0.2 seconds. And then you could also define a kind of a daemon flag. So we could write daemon flag is equal to true. Now what this would do is, if the daemon flag is not true, so if not daemon flag, then we could just break out of this loop, which would ultimately kill the thread. So, and we could possibly just move it over here. There you go. So now let's say down in the program somewhere we are done with the sniffing function and we want the daemon flag to stop. So we could just switch the daemon flag to the daemon flag to false, and then we could just, this value would be false, so a not would be true. This would go inside this condition and the break would be applied, which would basically jump out of this thread, jump out of this infinite loop, which would ultimately kill the thread. So that's the use of the daemon flag. So the channel hopper function is ready, and I think now we should move on to sniffing the actual packets. So the way we sniff packets is, we just used, I had shown you this also like 5 minutes ago. We write the sniff function, and there is something called as the prn, which basically accepts a function. And what would happen is, if I write in prn is equal to handler, every packet that Scapy would sniff, it would pass that packet to the handler function. So def, we define the handler function now, which would take in a packet. Also, we need to write in const.iFace is equal to iFace. So now we wouldn't have to if we won't do this every time we run the sniff function, we have to supply this iFace would be equal to lan 0 or whatever iFace. But now we won't have that issue. So we're going to be sniffing for the beacon frames over here. So I'll just give a comment, sniffing for beacon frames for access points. So now we are going to be implementing the same logic which we had implemented previously while we were manually sniffing for packets. So before we start the sniff function, we need to start the hopper thread, right? So hopper thread would be equal to threading dot thread, and the target of that thread should be the channel hopper function, and then we also import threading, and then we could just do hopper thread dot start of the channel hopper thread. And then once we are sniffing it, the only way to quit sniffing is when we hit ctrl plus C, and once we hit that, we're going to be setting the daemon flag to false, which would kill the channel hopper thread. And now we have got this ready, so let's write the logic for sniffing packets. So the first thing is we need to check whether the packet has the .11 beacon frame or not. So if there would be the biggest, so we're going to be writing an if case basically. So if packet dot has layer dot 11 beacon, it was .11 beacon, right? Let me see, .11 beacon, there you go. So this is the only case in which we continue scanning for the stuff in this packet. So if it has the .11 beacon frame, we get the .11 layer is equal to packet dot get layer, and then we get the .11 layer, and then we set we get the .11 layer, and then we get the .11 layer, and then over here, if we refer back to our structure, we would see the ADR2 or 3 both have the MAC ID. So we could just type in MAC ID is equal to ADDR, let's say .11 underscore layer dot ADDR2, or even 3 would work, so whatever you want. So we now have the MAC ID, so let's comment that also. We have the MAC ID, and then we could essentially scan for another. We have the MAC ID, and then we would. So now we have the MAC ID, and now we are looking for the channel name and the beacon and the. So now we have the MAC ID. Now we're looking for the Wi-Fi's name and the channel on which it is operating. So now we can get the beacon frame. So beacon frame would be equal to packet dot get layer dot 11 beacon. And then once we get the beacon frame, we could go to the payload, and then we could go to the info. So name is equal to beacon name is equal to beacon frame dot payload dot info. And if you remember, the info was in binary, so we need to decode it. So we write dot decode, and we use the ASCII decoding. So we would have the name now. So we have the name now, and now the only thing remaining is the channel number. So we would just be getting the DSS parameter set. So to do that, we type in DSS layer. It's basically the same thing we are just which we did like 5 minutes ago. We're just now automating that using Python. So DSS layer would be equal to packet dot get packet.get layer, and we get the DSS parameter set. So that would be dot 11 ELT DSS set. Once we have that, the channel would be equal to DSS layer dot channel, and now we have the channel number. So now we have the MAC ID, the name, and the channel number. So let's formulate a data. Data would be a kind of an array. So the first thing, let's first define the syntax of data. So the syntax of data would be something like this: syntax of data. So the first thing would be the name, then the MAC ID, and then the channel number. So data would be equal to the name, so the name, then the MAC ID, and then the channel number. Right, so now we have this data array. So now we will define a master array which would basically keep track of all, which would basically act as a logbook. Once we scan for an access point, it would record that in the main master array. So let's call it, I don't know, let's call it the main array itself. Main array, it would be an empty array. So first of all, we would need to check whether the main array has this name or not. Basically, we don't want to log the same data again and again. So if data not in main array dot append data. So now I think we would be ready for running this program. I think this is enough for sniffing function, sniffing for the access points. I think once we are done over here, we could just print everything which is in the main array. So let's do for main data in main array. I'm terrible at naming my variables. We could just do print main data. So let's try to run that. I'm definitely sure there are going to be like a million errors, but let me run it anyways. So I'm going to quit this and then switch to desktop, and I think this is where I had my files, jammer.py. So let's run jammer.py and main data in main array. Okay, I didn't know this would be an error. For main data in main array, print main data. Okay, let's just do print main array. Let's just see what happens then. So run this program, and I forgot to print any kind of stuff, so we just have to hope that it's scanning for stuff, and there you go, it actually scanned for stuff. So if we just maximize this, apart from that basic syntax error while we were printing that array, I don't think we had any other kind of an error. So I think another thing which we could do is we could just, instead of like printing the main array like this, when we are appending the data, we could just print, we could also make an index. We'll do that later, but we could just print the data over here. So we could do that. So let me run the program again, and there you go, it's working. So if you see, there is a lot of different channels over here, a lot of different Wi-Fi networks over here. All the H3 ones are basically, I live in a hostel in my college, so these are all the Wi-Fi networks of my college, and I'm not going to be jamming them. I think it's illegal, but I'm going to be working only on my my network, which should be on channel 6. And where is it? I have to basically look through all of this. Okay, my mobile hotspot was actually off. Let me turn it on again, and then it should scan for my device. There you go. Yeah, and there are some weird stuff also, like you see these are like empty strings. We could write a logic to like not consider them. We could even write a logic to discard whatever this is. But anyways, this is my network, and we're going to be working on that. The last time it was a channel number 6, but now it's a channel number 11. But anyways, so now we have kind of a working Wi-Fi sniffer. So let me just close it, and let me just let's just write kind of a serial number basically. So we define let's say SSID counter, that should be equal to 0. And once we are printing the data, I'm going to be using global SSID counter, and then SSID counter is equal to SSID counter plus 1. Then we're going to be printing print number, and then concatenate that with SSID counter. I think we have to convert it to string first, and then I think we need to end this with like just a little bit of a space. Let's run this and see what's happening. Okay, this shouldn't have happened. Okay, there you go. That's the reason why. So now if we do run this again, this should work. There you go. So now we have a serial list, serial number. Why did I implement this? Because the next functionality would be, let's say we have scanned for all the access points, and okay, let's say we have scanned for all the access points. This is my network which I want to jam, and that would be number 8, right? So this is how we're going to be selecting the net. It would be easier for us to select the network, very easier for us. So we could there is a package called color AMA. You could install that using pip install color AMA. I already have it installed, so that's not an issue for me. But if you want to like add colors to your stuff, basically you could just like make it look a bit more beautiful. You could have a serial number tab over here, and then you could print these properly to basically make it look better. In the actual project which I have made and which is on my GitHub, I have implemented the colors also, but this is kind of just explaining you what the code is. Of course you can add the coloring on by yourself. So anyways, we have successfully made a channel hopper function. We have sniff for beacon frames to scan for access points, and now what we need to do is we need to select a network from the sniff networks and sniff for all the clients on that network. So we're going to be implementing this, and then we're going to be pushing all those data. We need to, first of all, we need to write logic to selecting the network itself, to selecting the network, and then we need to write logic for client sniffing, write logic to avoid client duplication. Basically the same thing which we had implemented in the beacon frames. We don't want the same Wi-Fi network to be logged multiple times. The same way we don't want the same client to be logged multiple times. So we need to write logic to avoid client duplication, and then we need to, I think these are the only 3 things we need to do. And then we need to write the Deauthentication function, which would basically loop through the, and yes, of course we need to, I forgot this, we need to push that data into an array or a list. And then in the deauthentication function, we are going to be looping through, so loop through the array, and then we're going to be crafting the deauthentication packets, and then we're going to be sending those packets to layer 2. So this is, so as you can see, we have a lot of more stuff to do, but it's going to be very easy, and let's move ahead with the second functionality. All right, now we want to write the code for client sniffing. The first thing I want to do is we want to select the network, right? So let's write the code for that. So now we have successfully sniffed for all the packets. So now we just write choice is equal to int input enter or select the network which you want to jam. And once we select the network, there should be one more brace. We would be accessing the main array, and the index of that network would be choice -1. What I mean by that is if I run this program again, if I do python jammer.py, you would see that, let's just pause it. You would see that, let's say I want to jam my network. The index number is 4, so the user is going to be entering 4, but the actual index of this is 3 because this starts from 0, so 0, 1, 2, and 3. So we're going to be using that logic. So the actual choice, while the actual index would be, while we were accessing the array, would be choice -1, and then we would be getting 3 things out of it: the name and the MAC ID and the channel number. So 1 second. Name and MAC ID and the channel number. So the name should be like this, and the name would be the first parameter. Like if we refer to the syntax of the data, the name is the first parameter, then is the MAC ID, then is the channel number. So name would be 0, then the MAC ID would be 1, then this would be 2, right? Also, now since we are only scanning for one network, we would switch our channel to whatever channel the network is operating on. So we do that using os.system sudo iw dev set channel format, and then the first thing should be the the first thing should be the interface, and the second thing should be the channel. So now after this, we could just also do os.system. We could clear the screen, and let's just print scanning. It would be the name and the MAC ID on channel number. Now let's format this using name. There should be braces over here. Name, MAC, and channel. So let's just run this and see what's happening. Let's do Python. I can never properly type when I'm recording, so, and let's just select the second network. So second network, and printf is not defined. Okay, I'm actually studying simultaneously C, so that's why I wrote printf, pardon me. So print and now let's select the first network, and there you go. Okay. And this printf also reminded me of that I'm thinking of making a video about reverse engineering and buffer overflows. That's the reason why I was revising on C. So maybe if you guys want that video, maybe you can comment it down. But I think I'm most probably going to upload that video maybe in this month, or maybe in the couple of next weeks. I also have my college examinations, so I need to take care of that also. So maybe by September end, I'll upload a video regarding reverse engineering using C and assembly. But anyways, so now we have this thing working. So now we need to sniff for packets, and let's push all of these packets to client handler. And now let's write the client handler, which will take in the packet. So now we are done with this. We need to write logic for client sniffing. I'm going to be sniffing client packets using these 4 packets: QoS with CCMP cipher, null frame, and control block frame. So I already have kind of a copy of these packets over here. I scan for these packets. You could do the same. You could basically do, let's say, packets is equal to sniff, and you could sniff for, let's say, like 100 packets. And after the sniffing is done, you could just do packets.end summary, and here you have all of these packets. Let me clear the screen. So here you go. So ignore these beacon frames and probe response. You would be looking for all those 4 packets. So now we have a null frame over here. So the index is 42. So let's do test is equal to packets and 42. If we do test.show, you would see this is the null frame. To identify the every packet when you sniff over the wireless network would have a .11 frame. So we get .11 frame. Let's do test is equal to test.getLayer.11 and test.subtype. So the subtype for the null frame should be equal to 4. So that's how we test for these data. And when the subtype is equal to 4, when you know that it's a null frame, you get the .11 layer, and right now the test is the .11 layer. And in the .11 layer, the ADDR1 would be the MAC ID of the network, and ADDR2 would be the MAC ID of the client. So this is how we identify the client network pair. And you could refer to the documentation, you could refer to what the architecture or what the structure of these packets are to get to know more about these stuff. But for our purpose, we could only know that in the case of null frame, ADDR1 is the network's MAC ID, and the 2 is the client's MAC ID. So we're going to be implementing this logic in Python in our program. So let me just open them side to side. So there you go. And now the client handler function. Okay, so now let's first write the logic for, first we get the .11 layer. So we write 11, .11 would be equal to packet.getLayer.11. Now we have the .11 layer. Now the first thing we scan for is the null frame, let's say, because we already have it open here, null frame. Actually, I had separately made scan for these things. So null frame, let's do null frame.show. So this is what a null frame looks like. So scanning for null frame is when we have the .11 layer, we check the subtype. So null frame dot payload dot subtype, and the subtype should be 4. So if .11 dot subtype is equal to 4, we have null frame. So what we do then is, as I had said before, in null frame, the ADDR1, I think I should write it over here like this. ADDR1 is the MAC ID of the network, while ADDR2 is the MAC ID of the client. Let me refer to my notes to reconfirm this. Packet.subtype is 4, ADDR1 is the MAC ID of the network, and ADDR2 is the MAC ID of the client, right? So we're going to be extracting that. So let's say network is equal to .11.addr1, right? And client, let's just put C is equal to .11.addr2. So now we need to check for 2 things. We need to check whether the network is equal to the MAC ID of the network which we're actually scanning from. So the first condition would be network is equal to MAC, and the second condition would be if we already haven't logged this client. We don't want client duplication, so C not in clients array. That also reminds me of the fact that we have to declare a clients array, which would basically store all of the clients. So the network should be equal to MAC, and C should not be in the clients array. So if that is true, we append this clients array dot append, we append C, and this is the logic for the null frame. So now we're going to be writing similar logic for the control block frame. So control block frame, And see, if when a packet is null frame, it's not going to be control block frame. So we're going to be using elif. And now let me open the control block frame now. So control block frame dot show. This is what the control block frame looks like. And let me get the payload, which is .11 layer. Okay, payload. The spelling of payload is wrong. So payload.show. This should work. There you go. So now we have the subtype ADDR1, ADDR2. So how do we scan for control block frame? We again use the concept of scanning through subtype. So we do, let's say, control block frame dot payload dot subtype. The subtype is 9. So if elif dot 11 dot subtype is equal to 9, we have a control block frame. And in the control block frame, I believe it's the opposite of the null frame. In null frame, we had ADDR1 was the MAC ID and ADDR2 was the client ID. In control block frame, we have ADDR2 as the MAC ID and ADDR1 as the client ID. So ADDR2 is the MAC ID of the network. So MAC ID of the network, while ADDR1 is the client MAC ID. So it's the opposite of what we had made before, right? This should be a while. So ADDR1 is the MAC ID of the network, but over here ADDR2 is the MAC ID of the network. So we extract that using the same logic. We could even copy this code, but let's just write it down. So network is equal to .11.ADDR2, right? ADDR2 is MAC ID of the network, yes, and C would be equal to .11.ADDR1. So we add the same logic again. So if network is equal to MAC and C is not in client's array, then we're going to be appending the value of the client MAC ID. So client's array dot append C. So now we have the control block frame, and now we're going to be writing the logic for the quality of service frame and the quality of service with CCMP cipher frame. So the way we do it, I already have a quality of service frame also here. So let's clear the screen and let's write QoS frame. And QoS frame is, okay, it was QoS packet. I'm sorry, QoS packet. Let's do QoS packet dot show. And here we can see in the QoS packet, we have a QoS frame, right? So we could just essentially do elif packet dot has layer QoS, and the way we scan for QoS is, I believe, let me just refer to the notes again, layers and wireless network layers, okay, and QoS, so .11 QoN capital S, okay. So this is how we refer to the QoS packet. So over here, the packet has .11 QoS. If the packet has .11 QoS, we are now in the QoS frames. So now there are two conditions. The packet could be just a generic QoS frame, or it could be a QoS with a CCMP cipher frame, and the logic is going to be a bit different. Basically, the same thing. ADDR1, ADDR2 is going to be interchanged. One is the MAC ID of the network, other is the client ID, and if, let's say, in the CCMP cipher, those values are going to be reversed. So what we do is we write a logic in a way that if the packet that which we have scanned for, if it does not have .11 CCMP cipher, so if packet dot has layer .11 CCMP, and we write a not over here. So if packet not has .11 CCMP cipher, we have generic QoS frame without CCMP, And the way we get the data is then ADDR2 would be the client's ID and 1 would be the MAC ID of the network. So ADDR1 would be network and ADDR2 would be client. So we write those data down. So network would be equal to ADDR1.11.ADDR1. So .11.ADDR1 and client or C would be .11.ADDR2. Now we're going to be writing the same logic. If network is equal to MAC and C is C not in client's array, then we're going to be appending this data to the client's array. And if that's not the case, like if the packet, we wrote the case when the packet does not have a CCMP cipher, this else block would deal with the packet having the CCMP cipher. This means this is a packet with CCMP cipher. So the syntax for this would be, if I refer back to my notes, CCMP with, and by notes I basically mean the project which I had already made, so you can also refer to them on my GitHub, which would be linked in the description down below, the repository. So here things are just the opposite. Address 1 is the client and address 2 is the network. So ADDR2 over here would be the MAC ID of the networks. ADDR2 would be network and ADDR1 would be client. So you could see it's opposite. ADDR1 in this case was the network, but over here ADDR2 is the network, and the client is ADDR2, but over here the client is ADDR1. So we extract these data. So network is equal to .11.ADDR2 and C would be equal to .11.ADDR1. So we write the same logic again. If network, when you are making this program, what you could do is this logic of checking these two conditions, you could just pass it into a function and you could just call this function which would return a Boolean value. So we won't have to write this logic again and again, but this is the last time I have to write it, so I'm not going to implement that function, but you could do it when you're making this project. And C is not in client's array, so we would be appending this data again, client's array dot append C. So now we have logic for null frame, control block frame, QoS frame without CCMP and with CCMP cipher. So now once we are done with this, let's just and also I forgot to do it. We could just print the number. We could just print the client which was scanned, and also we need to declare a counter. Basically count the number of clients. So clients, let's say client counter is equal to 0, and in the handler function we declare global client counter, and then if we are appending the data, we increase the client counter. Client counter is equal to client counter plus 1, and then we print this using hash, and then we append that using the string value of the client counter, and then we could just also append the client's array or the value of C itself. Now we're going to be copying this logic while we are appending in all of the other three conditions. So control block frame and QoS without cipher and QoS with cipher. And let me just check if everything is working or not. So we are going to be increasing the client counter. We're going to be printing the client counter and then C. Okay. Maybe we could also implement or add some kind of a space. So this would work. think so. I'm pretty sure there's gonna be some kind of a bug, but anyways, so let's do this and let's just print exiting from the function. Let's save this and let's see how many errors are there. So let's clear this. Let's do python jammer.py. Okay, there should be an if block or line 102. Okay, so line 102, we go to line 102, and if not, okay, so what's the error again? Okay, so indentation error, expected an indentated block. Okay, this has to be indentated, of course. So tab. I have to write like 1,000,000 tabs now, and then even this has to be indentated. I think then we are good. Line 104. Okay, I'll just get rid of this entire thing. Okay, so I don't know why, but every time I use multi-line comments, there has to be some kind of a bug. I don't know why, but 114, I didn't save it. Yes, there you go. Okay, so now let's select the first network and let's see what happens then. So it's gonna take a while basically, and even the project which I had made, it would take like 1 minute or 2 minutes to scan for the clients, because it is scanning for four specific intricate packets, and that's the issue basically over here. You would never know if there is a bug or it's actually the waiting time. So I'll just pause this video and let's see what happens after a couple of minutes. I had to wait for like 90 seconds to get these results. So I had my computer connected to my network. So the MAC ID of the computer is C0B6 blah blah blah. So we have successfully implemented a scanner. So now we could scratch that off of our to-do list. So we have written the logic for client sniffing, avoid client duplication, and then we are pushing data into a client's array list. So we have dealt with probably the most major part of this video, and we also have scanned for these packets. Now we just need to write the deauthentication function, which would loop through the array and then craft the deauthentication packets and send those packets to layer 2. Alright, now we have to implement the third functionality, which is to make the deauthentication function and to then craft and send the deauthentication packets to the clients. So if I open my notes, it should be here. Okay, so we need to add the deauthentication function. We need to loop through the array, craft and send those packets. Also, we need to give the option to choose which clients we want to jam off the network. What I basically mean by this is, let's say we have a program over here. The clients array would have this would have data or the MAC ID of all the clients connected to the network. Okay, never type properly when I'm recording. Okay, so this would have the MAC ID of all the clients. So basically, let's say there are 2 clients. Let's say we have client 1 X and we have client 2 Z. Now let's say we want to jam only client X, or let's say in the first scenario we want to jam all of the clients. So we don't change anything in the clients array. What we are trying to do ultimately is, while we are jamming, what we're going to be doing is we're going to be looping through the array. So for client and clients array, and then we're going to be crafting and sending the deauth packet to the client, basically the element in the client's array. So if we are like jamming all of these, and this has to be in a, this will be in a while true loop. This would run forever. So now, if we are jamming, let's say both of the devices, we don't need to change anything, because basically when we would be looping through this, the first client would be X, the second client would be Z. Then the while loop, since it is in a while loop, we would again run this program, this loop again, this for loop again. So we wouldn't have to change it. But let's say we only want to jam network Z. So the index of this would be 0 and the index would be 1. So when we choose, let's say we devise a convention, -1 means jamming all the clients. In this case we do nothing. But let's say we enter 2. That means we want to jam the second client. So what do we do then is, the index would be 2 minus 1, that would be 1, and then we set the clients array to be equal to clients array, and we use the index clients array, the value of let's say we store this in a variable called choice, let's say option. So clients array option -1. So now the clients array would only consist of Z. So while we would be looping through this, the loop would only send the package to Z, because that's the only element in the array. So this is the functionality which we want to implement. So let's first print just a normal line, and then let's take an input. So option is equal to int input, enter the client which we want to jam, -1 to jam all the devices, right? And once we got that, I think if option is equal to -1, we do nothing. But if option is not equal to -1, we would do something. So if option is not equal to -1, and let me put this in braces, option is not equal to -1, then what we're going to be doing is the clients array would be equal to the clients array option -1. So now let's just print the clients array to see if it's working or not. Or I don't think we need to print it. It's a very basic logic. So now we have the clients array. So now we need to write the logic for looping. So we do while, first we write infinite loop. So while true, inside the while loop we do for client and clients array, and then we craft the deauthentication packet. So packet would be equal to, now the deauthentication packet would consist of 3 layers. If I draw it over here, the first would be the authentication packet. So the first layer would be the radio tap layer, which would basically, it's a very generic layer. The second would be the .11 layer, and the .11 layer would have 3 parameters: address 1, 2 and 3. Address 1 would be the MAC ID of the client. This should be the MAC ID of the client, and 2 and 3 should be the MAC ID of the network. So in our case, that's the capital MAC. This is also the capital MAC. And then the last layer would be the .11 deauth layer. Basically, this would add all of the remaining information on its own. We don't need to manually pass that logic. So this would what our layer would look like. This is what our packet would look like. And to send this, we use the send p, and then we send this packet to layer 2. If you know just a bit about Scapy's logic, send packet would send this to layer 3, but send p would send this to layer 2, which is what we want, right? So we're going to be implementing this logic. So first we write the radio tap layer, which would be in Pascal case, and then we have the .11 layer. .11 layer, and the ADDR1 is the client's MAC ID, and ADDR2 is the MAC ID of the network, which is capital Max, and ADDR3 is again the MAC ID of the network. And then we also add the .11 Deauth layer. Let's make this a little bit more bigger. Okay, so now we have our packet ready, and then we're going to be sending this packet on layer 2, and this is it. Alright, so one more thing which I wanted to mention was over here, when we are like selecting one particular client which we want to jam, that client has to be within an array. So this should be within square braces, and then I think we are good to go. So now we have given the option to choose which clients we want to jam off the network. We are looping through the array, we are crafting the deauth packets, and then we are sending those packets to layer 2. So I think we are done with the program. Let's run this program. I'm going to be running this program on my machine, on my actual machine. So this is my actual machine. If I open CMD, you would see that this machine is connected to my Galaxy network. So let me just type in, I don't know, ping google.com. Let's give it a count of 5,000. So it's going to be pinging google.com for 5,000, sending 5,000 packets. And by that time, let's run this program and see what happens. So this was my program. Let's save it, and now let's run it. So let's do python jammer.py, and we would be scanning for Galaxy S20 15. Let me just reconfirm. I'll show you also Galaxy S20. Here you go, Galaxy S20, and we're going to be selecting number 15. So now it's going to be scanning for my MAC ID. The MAC ID of my the actual laptop which we're going to be jamming starts with C0. So that's how we're going to be knowing it's our laptop. So this would take like a couple of minutes. So it took me like kind of 30 seconds to find the client. So as I said, C0, the MAC ID starting with C0 belonged to my actual laptop, that denoted the actual laptop. And over here I have pinged google.com, and the count is of 10,000. So I'll start it again. Let's just clear the screen and do ping google.com, and let's do 10,000. And as you can see, we are receiving replies right now, but let's now start the jammer attack. Let's do the first device, and let's see what happens. So as you can see, the ping replies have stopped to appear, and we are getting requests timed out. And even over here, if you see, this sign has changed from connected to not connected because we are jamming this profile. Now let's hit Control C into our main function, the jammer function, and then we could disconnect back to our Galaxy device, and then there you go, we have restored connection. So this is how a jammer program would work basically. And if you have watched the entire video, if you have any kind of queries, you can ask me in the comment section. And if you have any kind of constructive criticism to make this program better, maybe you could implement multi-threading. I was thinking of implementing multi-threading to scan through different networks, but that's a project which I'll do maybe in the future. But yeah, if you have any queries, you can ask me in the comment section. And if you found this video informative, please consider subscribing and liking my channel. I know I'm very inconsistent with my YouTube upload schedule, but I have a lot of other things to manage also, so it's very hard for me to make videos like weekly or like once in 2 weeks. But I'll try to upload more videos. And yeah, thanks for watching, and thank you, bye bye.